All right, we're on the back. We're going to start with problem 9. One thing I did suggest in all the classes, though, is take your outer set of parentheses and make them just a little bit bigger. And what's inside these bigger parentheses is what should substitute in. So on number 9, G is supposed to go into F. So that means all of this is going to go into this x. So I'll still have the 2 and the 3 there, but instead of 2 times x, it'll be 2 times 4x squared plus 3. And now when I look at this, I want to see how can I clean this up? Well, I have these parentheses there because of the 2, and the 2 wants to multiply. So I'm just going to take the 2 times the 4, and then this is cleaned up. So this is my new function, 8x squared plus 3. And now I'm going to go for the domain. So when I go for the domain, I'm going to ask myself, do I have x in a denominator, x in an even root, both, or is this good to go? This is good to go. I don't have any issues, so I'm just going to put ARN, all real numbers. On number 10, this time it flips. This time I want to take F and put it into G. So the 4 is still there, but instead of x being squared, I'm going to have 2x plus 3 squared. Now this one I talked about in a couple of classes. These parentheses are there. There's a 4, and then there's the exponent of 2. The 2 gets the parentheses first, but you cannot just distribute the 2 in because there's addition in there. Instead, we're going to have to take and do what the squared really wants, which is to take 2x plus 3 times 2x plus 3. So what I'm going to first do is FOIL this. So when I take my first terms, 2x and 2x gives me 4x squared. And then I'm going to take 2x and 3, which will give me 6x. And then I'm going to take another 3 and 2x, which will give me another 6x. So I'm just going to add those right now and make it 12x. And then 3 and 3 will give me 9. And then all of that is now times the 4 that's there. So when I take 4 to each term here, I get 16x squared plus 48x plus 36. And that's what I'll put in my final blank answer then. And again, I'm going to ask myself, do I have x in a denominator, x in an even root, both, or is this good to go? This one's good to go, all real numbers. All right, on the last one, I'm going to take h of x, and this time all of this, g of x is going into h of x, and it's going to go into both of these x's. So instead of x being squared, I'm going to have 4x squared being squared. I still have the plus 5, and then it's over 4x squared. Again, I have parentheses. The reason why the parentheses are there is for the 2. Here I can distribute the 2 in because it's multiplication, the parentheses, not addition like it was here. All right, so going back to this, I'm going to square the 4. I'm going to square the 4 for 16. I'm going to square the x squared and make it x to the 4th plus 5 over 4x squared. And then this addition subtraction, I'm going to wrap in parentheses because I cannot break up the addition subtraction. It stays as a whole. So even though we might want to think, oh, I can take an x from the numerator and the bottom out, or I can take a 4 out of the 16 and the 4, you can't. This is it. This is your new function. So this is what's going to go up in the empty spot. Whoops, not x to the 4th. And here when I ask myself, do I have any issues with the domain? I do. I have an x in the denominator. So just kind of moving off to the side, I'm going to take the whole denominator and I'm going to use this issue. It can't be 0. So I'm going to divide by 4 first. Square root, the square root of 0 is just 0. So that's my domain. If I were to make a t-chart, I would not put 0 on my t-chart. All right, almost done. Let's go to the last two. On 11, I am multiplying the two functions. So when I multiply the two functions, I'm going to take g of x, and I'm actually going to rewrite it so it's in standard form. Here's g of x rewritten, and f of x And I've added the opposite already as I wrote it down, and I'm going to distribute. So the negative x squared is going to go to both things. And remember, since I'm multiplying, I'm going to add the exponents. So negative x squared and x cubed is negative x to the fifth. Negative x squared and negative x squared is a positive x to the fourth. And now the 3 is going to go through. So 3 to x cubed and 3 to negative x squared. And then from here, I can't do anything. This is as good as it's going to be. This is what would go in the blank. It's in standard form. It's all different. I can't combine any like terms. And again, I don't have x in a denominator, x in an even root. This is good to go. So this is in all real numbers. In the last problem, I am going to take g of x, and I'm going to subtract f of x. And I'm putting this in parentheses because I'm supposed to subtract the whole function. And now I'm going to go through and add the opposite. So when I add the opposite, this minus x squared is going to become plus negative x squared. And when I add the opposite here, this positive x cubed will become negative x cubed, and the opposite of subtracting x squared is adding x squared. So now when I'm ready to add my like terms, the first thing that I notice is that my x squareds will cancel out. And then when I look at what's left, I can't combine these because they're not alike. So when I put my answer here, I'm just going to write it in standard form. And again, no issues with my domain. No x's in the denominator and even roots. So again, I have all real numbers. And that's it. That's the review. Tomorrow, make sure the review's done. Bring in your flowcharts and your exponent table, and we'll see you then.